Previously, when we worked on factoring trinomials, we've always been given examples where the leading coefficient is 1, meaning the coefficient in the first term with the x squared variable is 1, or it can be factored so that the leading coefficient becomes 1. However, this won't always be the case. For example, we might be given the question 2x squared plus x minus 15, and we'll be asked to factor it. This is a bit of a different situation because, as I mentioned, the first coefficient is not 1. There are several ways to tackle these tough trinomials, however, both start the exact same way. The first step is to common factor if possible. In this case, there is no common factor, so we can skip that step. And the second step is to use the sum and product method that we covered when factoring regular trinomials. Let's begin by looking at the sum. The sum here is positive 1. The product is negative 15. But wait, this is actually not the product when we're dealing with tough trinomials. Normally we would look at the last term to see what the product is. However, because we now have a different coefficient at the beginning, we need to consider this in the product as well. So if we multiply the coefficients of positive 2 times negative 15, the product is actually negative 30. And that's how we always need to calculate the product for tough trinomial questions. Here we're looking for two numbers that will give us a negative product but a positive sum. And the sum is 1, so the numbers have to only be 1 apart, meaning that the resulting numbers will be 5 and 6. And since it's a negative product with a positive sum, we're going to have a negative 5 and a positive 6 as the two numbers. Now that we've found the numbers, we can branch off into the two separate factoring techniques. The first is decomposition. So this is the same method that we used when factoring regular trinomials, and that is to replace the middle term in the expression with the two numbers that we found. So what that looks like is, remember, we keep the first and last terms as is, and we replace the positive x with a negative 5x plus 6x, and then we factor by grouping. Looking at the first set of terms, we common factor out an x, leaving 2x minus 5, and in the second set of terms, we factor out a 3, again leaving 2x minus 5. And in the final step, we factor the 2x minus 5 out of both terms, so the final result is 2x minus 5, x plus 3. So this method works, and it doesn't take too long. However, there is a shortcut method that we can use. In the shortcut method, we're going to start by writing two sets of parentheses. In both parentheses, we're going to use the coefficient of 2 from the original expression, and then we're going to take the square root of whatever the variable is. So here, the variable is x squared, so the square root of x squared is x. So the same thing applies if you have a higher power of x. If it's x to the power 4, your square root would be x squared, and that's what you would put in both sets of parentheses. The next step is to take the two numbers that you found and add them into each set of parentheses. So we have the negative 5 here and the positive 6 here. And the next step is to divide off any common factors. This is the only time in the middle of a factoring exercise where you're not going to factor out the common factor, you're going to be dividing it. However, if there is a common factor at the beginning, you absolutely must factor it out, otherwise that will mess things up with the shortcut. So here we have 2x plus 6. The common factor is 2, so let's just divide that off. And then we'll rewrite the factors here, now applying that to division of 2, leaving us with x plus 3. And if you recall, that was the same answer we got using the decomposition method. Looking at this second example, we'll start the same way. So we'll look at the sum being negative 13. The product is, remember, 12 times negative 4, which is negative 48. So thinking of some numbers that multiply to give you negative 48, ultimately we're looking for one negative number and one positive number, with the negative number being the larger of the two. So we can start with negative 8 times 6, This will not give us a sum of negative 13. Same thing, negative 12 times 4. Again, the sum will be different than negative 13. However, negative 16 times 3 will work. So continuing with the decomposition method, we just want to replace the negative 13x with negative 16x plus 3x. And we'll keep the negative 4 as is. And then proceed to factor by grouping. So in the first set of terms, that's these ones here, we have a common factor of 4x, leaving us with 3x minus 4. And in the second set of terms, there's no common factor, so we just factor out a 1 and leave 3x minus 4 as is. And finally, we're left with 3x minus 4 multiplied by 4x plus 1. Now let's look at the shortcut method. So the shortcut method is to write a 12x in both sets of parentheses to start. Just to reiterate, that is the coefficient of the first term and the square root of the variable of the first term. Next, we're going to take the numbers that we found and include them in both sets of parentheses. And finally, we're dividing off any common factors. So in the first set, we can divide by 4, and in the second set, we can divide by 3. The resulting answer will be 3x minus 4 multiplied by 4x plus 1. I hope these examples helped you understand how to factor tough trinomials. If you have any questions at all, feel free to ask me in the comments section. See you next time.